Hello everyone! So today I'm going to talk to you about fractional exponents. Just as regular exponents are another way to write a multiplication expression, fractional or radical exponents are another way to express roots, which are essentially the reverse of exponents. Let's look at an example of a normal exponent, 5 squared. This simply means that 5 is multiplied by itself 2 times. Exponents show how many times a base number is multiplied by itself. You might look at this expression and think, oh, this is 5 times 2. This is incorrect, because you can rewrite 5 times 2 in terms of addition, meaning it is an expansion of addition. We can rewrite 5 times 2 to say 5 plus 5, but that's not what we're trying to find. Exponents are an expansion of multiplication, because it is how many times a number is multiplied by itself. So this means 5 to the second power is 5 times 5. Because we multiply 5 by itself 1, 2 times. We get an answer of 25. Here's another example, 2 to the 5th power. Now this means that 2 is multiplied by itself 1, 2, 3, 4, 5 times. So let's solve this. 2 times 2 is 4, times 2 times 2 is 4, bring down the 2. 4 times 4 is 16, bring down the 2. 16 times 2 is 32, so our answer is 32. Now let's look at square roots. Let's take the square root of 25. This is the reverse of the exponent. We're trying to find what number, n, when multiplied by itself, gives us 25. Now we saw in the previous problem that this number here is our base, and how many times we see that number is our exponent. So we have 1, 2 n's, which equals 25. Now, if we were given this equation, using basic algebraic principles, we would solve by taking the square root, since that's the opposite, and these two cancel out, that would give us our answer. Another way to do the same operation is to put it to the 1/2 power on both sides. This works because of exponent laws. We know that when we have an exponent inside parentheses, like here, raised to another exponent, you multiply the two exponents together. 2 times 1/2 equals 1. That means something to the second power and something to the 1/2 power cancel out. We saw earlier that square root and squares cancel each other out, so this means the square root of a number is equal to raising that number to the 1/2 power. This is all that fractional exponents are, another way to express a root. The answer to 25 to the 1/2 power, or the square root of 25, we saw earlier it was 5, since 5 times 5 equals 25. It can also be -5, since -5 times -5 also is 25. Keep that in mind when solving roots. Here's another example, the 5th root of 32. We want to know what number, n, when multiplied by itself 1, 2, 3, 4, 5 times, equals 32. We can rewrite this in terms of an exponent, n to the 5th power, since we have 5 n's, equals 32. If we wanted to get the original expression, we would take the 5th root of both sides. These two cancel out. Just like the square root, we can rewrite using fractional exponents. We can raise both sides to the 1/5 power. Since 5 times 1/5 equals 1, they cancel out. This means a 5th root of a number is equal to raising that same number to the 1/5 power. We saw earlier 32 raised to the 1/5 power, or the 5th root of 32, is 2, since 2 times 2 times 2 times 2 times 2 equals 32. General rule for fractional exponents, we have the x root of a number, n, is equivalent to that same number, n, raised to 1 over x power. Now here's a harder example, 9 to the 3/2 power. This looks new. If we look at our generic rule, the x root of a number is equal to n to the 1 over x power. Here we are assuming n is to the first power, and that's how we got this 1 right here in the numerator. If we wrote a rule to say the x root of n to the y power equals n to the y over x, now this works for all fractional exponents, and is more like our example here. I'm going to go a step further and put this whole thing in parentheses and raise it to the power of y, This makes the problem easier to solve. So let's go back to our original problem, 9 to the 3 over 2 power, and rewrite it in terms of this expression. X is 2, since that's our denominator of our exponent, but I left it off since we know that means square root. N is 9, that's our base, and Y is 3, since that's in the numerator of our exponent. The square root of 9 is 3. 3 to the 3rd power is 27. Now you try switching from radical form to fractional exponent and vice versa. Now keep in mind, the rule only applies to what is raised to the exponent, so this 17 here is left alone. Pause the video and then come back and check your answers. Okay, let's check our answers. This first one, x to the 5 over 4 power, as a radical, can be written as the 4th root of x to the 5th power. This 4 is our root, because it's the denominator. This 5 is our numerator, so it goes with the x. The answer to this one is 4x cubed. This one was a little tricky. We had a cube root of a normal number, 64. We want to figure out what number times itself 3 times gives us 64. This is 4, because 4 times 4 is 16. 16 times 4 is 64. That's how we got this 4. And then when you rewrote this in terms of a fractional exponent, you got x over 9 over 3. X to the 9 over 3 power, sorry. And when you reduce that, 9 divided by 3 is 3. So that's how we got x to the 3rd. Final answer is 4x to the 3rd. The answer to this one is 17, 7th root of x to the 3rd. Now, like I said, the 17 is left alone, so it stays out front. Lastly, the answer to this one is x to the 5 over 8 power. That's all I have for today. Thanks for watching.